A huge thanks to Mr. Saeed Amen for joining here. Could you just start with a quick introduction to Turnleaf Analytics, what you do, and your work in quantitative macro markets?
Yeah, sure. So I'm Saeed Amen. I'm one of the co-founders of Turnleaf Analytics alongside Alexander Denev. And the team essentially does inflation forecasting. We do that for 35 countries. But our approach is a data-driven approach. So we use machine learning, a lot of alternative data. So it's less of a more traditional approach where you have a narrative and then come up with your forecast. And in terms of my background in macro markets, I've mostly worked in FX during my career. I still do a bit of work on FX with Turnleaf, but these days my focus is on inflation. But I've been on the macro side as opposed to kind of micro, and I would say like equities and that type of thing. I've worked always in FX and inflation.
Okay, no, awesome. And then just you mentioned alternative data, and that's a bit of a unique approach that you're taking with all machine learning forecasting.
Yeah, so alternative data is something I wouldn't say that we're the only people that use alternative data, but I remember looking at alternative data many years ago when it wasn't called alternative data. This is like in 2007 or that type of time. And alternative data is essentially data that is not commonly used within financial markets. And Alex Denev and myself, we actually wrote a book, the Book of Alternative Data. Maybe we could have come up with a more original title. We published that 5 years ago to bring together many different strands of interest in this area. And yeah, alternative data is data that typically you wouldn't find in financial markets. So more traditional data sets are more like things like the prices of assets, GDP, inflation data, all these types of things are kind of more traditional data that you tend to use in financial markets. But alternative data could be, for example, text. So it could be text from newspapers, from social media, and you can use that to gain an insight into the sentiment. It could also be satellite photography as well. So satellite photography can be useful, for example, for understanding how busy car parks there are in, say, supermarkets, so you can get an idea of their profitability and this type of thing. So the meaning of alternative data is more traditional data. Is basically anything but traditional data, I would say, for financial markets. But these days, more and more people are using it, but it's still, I would say, we still haven't scratched the surface as an industry, even though the uptake in terms of alternative data is way higher than it was, say, 5 years ago, and definitely 10 years ago in financial markets. But there's still a long way to go. And I would say in terms of alternative data, there's a lot more people using alternative data who are investing and trading in equities than those in macro markets. So things like FX, inflation, rates, and that type of thing. I'd say still for macro, I think alternative data is still a relatively new concept.
Okay, I know. And then, how do you actually like measure the if whether it like data set, alternative data set has any financial value?
So that's an extremely good question. So there's lots of ways of doing it, but purely in the context of what we do in terms of inflation forecasting, we have a regression model where we're trying to forecast as our Y variable CPI, as an example. So the way that we evaluate whether a new data set is useful, whether it's alternative data or a traditional data set, is we add it to our regression and see essentially does it improve the fit. But unfortunately, it's not always that simple because sometimes the initial data set you get might be in a format which cannot be plugged immediately into a regression model. And equally, there might be a lot of additional work that you need to do, for example, to create an appropriate feature for it. So it's not an automatic thing that you suddenly get a data set and you can put it into your regression model. Often there needs to be a lot of additional work. But that's how we would do it in from an inflation forecasting perspective. If you're trading, for example, FX or rates, equally, you might have a forecast that you're trying to improve, or you can try and create a trading rule around the new data set or add it in the context of a trading rule that you're already using. But there's not a one size fits all, unfortunately. But that is something that people are looking at a lot these days. Can you easily evaluate whether alternative data is useful for your use case or not? It is challenging because one person's incredibly useful alternative data sets might not necessarily be useful for other use cases. So It really depends upon your use cases and how you're constructing the features and doing the analysis around there.
Yeah, okay, no, that makes sense. And you're also a businessman with Turnleaf Analytics, and I mean, you need customers. So I was wondering what the kind of challenges you have faced with getting economists um, using Turnleaf Analytics, especially with the kind of machine learning and alternative data approach, which isn't like the standard way of doing it.
Yes, I think whenever you do something new or unusual, people ask questions in terms of why you're doing it in a different way and so on, which is fair enough. But I would say that with machine learning, the big advantage is that because of the large amount of data that we have these days, we can get more accurate forecasts using machine learning. So the big plus point is if you have the right data, that's the crucial point. If you have the right data, then you can get better forecasts using machine learning. And also it's complementary. So if you're using other techniques to do your forecasts, then maybe having a complementary technique, which is orthogonal, is useful from that perspective. So that's what we tell clients essentially to try and kind of get them to understand what we're doing and so on. But of course, with anything new, there is a bit of a phase of kind of discussion and trying to say why you're doing it and so on. Why have you changed the approach that people have always used? And in a sense, I'd say the lack of accuracy with particularly say over COVID and periods like that with more traditional models have basically pushed people to use these new techniques. So there's basically a need to use these techniques. And the whole point is it's a data-driven approach. Historically, it's been more of a narrative, especially with kind of more simple ones, it's more of a narrative-based approach, and then you get your forecast. With us, it's a data-driven approach. You get your forecast and then potentially the narrative. So it's not about making stories to construct your forecast. It's more about getting a view of the data essentially to begin with. But yeah, it's a good question, and I'm sure people are facing this now with LLMs as well, more broadly. Oh, that's a slightly different area to what we're doing. That's something new, always needs explanation and reasoning for people to want to take it on board and to use.
Yeah, and I understand that you found immense success, likely with Turnleaf Analytics, and in terms of especially inflation forecasting.
Yes, so our primary focus on inflation has been, yeah, inflation forecasting. We do forecast other variables as well, for example, ISM manufacturing and non-manufacturing, but the main part of what we do is inflation forecasting. We do that for many different countries, so both developed markets and emerging markets. You do have challenges, I would say, more broadly with, say, emerging markets, because there's not as much data as there is, for example, for the US, Eurozone, UK, and kind of the developed economies. And I'm pleased to say that our forecasts are one of the top ranked on Bloomberg. So at least for US CPI year on year, non-seasonally adjusted, Bloomberg have actually ranked us third for our short-term forecast, ahead of many investment banks. I'm not precisely sure how they do their rankings. I think the algorithm is not 100% public, but we're very pleased about that. And based on our metrics as well, we're compared to other forecasts on Bloomberg using our own metrics, we're actually top. But happy to have somebody independent like Bloomberg kind of verify our forecast and kind of tag us with one of the top ranks. So we're very pleased about that.
Yeah, no, it's very impressive, and a book that caught my eye is a book that you wrote, Trading Felicians, I believe. Yeah, can you just give a quick rundown on what that is about?
Yeah, so I wrote this around just over 10 years ago. Is my first book. And the idea of this is it was named after Thales of Miletus. So my friends Paul Billicon, Matthew Dixon, and it was actually Paul's idea to create a group called the Talesians, and it was named after Thales of Miletus. I happened to work with a good friend called Thales, and he explained to me about the philosopher and so on. So the book kind of grew out of the whole idea of that group and Thales of Miletus. And basically, Thales of Miletus was an ancient Greek philosopher, and there's a story about him which is written by Aristotle, saying that people were mocking Thales for being a philosopher, but saying, look, philosophers don't have any money and this type of thing. So what Thales wanted to do is he wanted to prove that he could make money if he wanted to by using his intellect. So he foresaw a great harvest in ancient Greece. So he brought up the use of olive presses during the low season. And when it was a great harvest, obviously everyone needed olive presses, and he made a lot of money out of that. So the key point there is his objective was not to have massive returns. It was just to show that he could make money. So the book kind of starts with this approach: is that if you want to be successful as a trader, maybe not trying to target massive returns is the way forward, but more trying to be successful with other metrics as well. Because if you just target your returns, you'll probably take too much risk, and potentially you'll over leverage yourself essentially. So it's full of little anecdotes and stories from the ancient world trying to illustrate what they can do to help us understand financial markets today. There's also a chapter on, for example, insurance, a chapter on history as well, the concept of history, looking back at Herodotus. So the idea of looking back at history is not necessarily just to recall events, but it's more to understand why certain events happened and so on and so forth. And there's the same looking at your own history of trading. You want to understand from your own history of trading what went right, what went wrong, and why, and you kind of learn from that as an iterative process. So despite the fact that the ancient world is obviously a long time ago, the point of the book was that there's a lot of wisdom that we could learn from the ancient world in terms of trading, and in particular starting with Thales of Miletus, who the book is essentially named after. So yeah, it was a really fun book to write, and I'm glad I wrote it at the time. So
It's interesting, and I saw you also have like a YouTube channel that's made around that concept, correct?
so some of the talks of the Telesians, the meetup group, we do put them online on the website. And actually, just trying to think, the first talk was actually in 2009. It's been over 15 years that we've been doing meetup events all around the world. So some of them are actually online and you can view them. Not every single talk, but a large number of the talks are there. Primarily, we currently do them in London and also in New York. But in the past, we also did it in other places like Budapest and so on. And it was, yeah, it's been a great experience to help organize them. Obviously, Paul kind of is his initial idea for the group, but I met a lot of interesting people, made a lot of friends through the meetup group. And it is interesting in this age of like internet and everything, and it makes it easy actually to create real life events. But at the same time, once you create real life events, you can actually meet people in person and so on. So it's not purely an online community. It's more trying to meet other people interested in quant and the like. And again, obviously, Telesians is named after Thales of Miletus, just like the book.
Okay, yeah, no. And is there any like methodologies or anything that you took from that kind of the ancient ways of thinking that he had and kind of implemented it in something like Turnleaf Analytics, for example?
Well, I would say it has impacted the way I think about trading strategies. So often when we do inflation forecasts, one big question from clients is, okay, how do I create a monetary value to this? Basically, how do I trade the inflation forecast? So we spend a lot of time coming up with use cases for inflation forecasting, and typically these are trading strategies. So the approach that I have whenever I develop a trading strategy is again not necessarily to target as high returns as possible. It's more trying to have a smooth trajectory of the history, trying to reduce your drawdowns and this type of thing. So you have other metrics that you're targeting when you create a trading strategy. So that's potentially one way that kind of the book has influenced my thinking. I would say in terms of how I look at research and that type of thing from the context of a trading strategy. And also like the idea that I mentioned about history, understanding what's happened. So we frequently, whenever we obviously running models live and we do a forecast, thankfully a lot of the times we hit the number, so we've got it right. But equally there'll be occasions, obviously, because it is a statistical model, right? You're not going to hit every single time. So on the occasions where we don't necessarily get the number, we look very carefully at the history. Why did we not hit? Is there a reason? Is there potentially data missing and so on? So it ends up being like an iterative process. So this is a crucial point, I would say, not just for inflation forecasting, but any sort of trading strategy or forecast, anything like that. You need to look at your history and try and understand what went right, what went wrong. And I would say it's very different compared to doing a back test. This is like offline research, where you do a study and see how something worked over the past 5 years, and you make a decision whether you want to run it live. Then when you start running it live, you'll continually, in a sense, have a loop of a real life back test, checking it, real life back test, and so on and so forth. So yeah, just learning from your actions, I would say, and particularly your mistakes, but also when things go right, trying to understand why things went right. But admittedly, I think, and this is true of life in general, you learn a lot more when things don't go your way. And then you try and improve it and so on. And this approach of like looking at how you've performed and kind of making improvements has actually been pretty important in terms of what we do at Turnleaf, because we've improved the accuracy of our models over time, understood where to tweak it, where we need to do more research and so on. But this is relevant for every area. It's not just for inflation forecasting.
Okay, and that makes sense. And on the topic of machine learning, on a bit of a more practical note, what's the most common kind of bottleneck or failure point that quantitative teams run into when moving a new machine learning model from testing into live production?
Well, I think the point of machine learning is it can. I'm not saying it's necessarily easy to do, but when you have a back test, it's easier to come, particularly with a more complicated model, to come up with a back test which works very well and it fits amazingly well. So potentially some of the pitfalls you have when you use a machine learning model, or even I would say any sort of model which when you go live, is potentially a degradation in performance because you've overfitted it on the past. So this is something that you need to be aware of. And one way to mitigate this is to try and use a model which is as simple as possible, but will capture the characteristics of your problem. Also to have the most appropriate data as well at the same time. And trying to make sure you have some sort of checks and balances when the thing is running live. So if it starts running live and it starts to kind of have a distribution which doesn't resemble the history, you know that something's wrong and you need to take action. But unfortunately, lots of problems, the amount of data that you have will be limited. This is different in something, even for example, with LLMs these days, there's only so much text on the internet, and you're getting to a stage where they kind of harvested everything. So even these are hitting their limits. But I'd say in lots of problems in finance, actually you have a small data set by comparison. So this also kind of impacts what sort of models you want to use, essentially. But I'd say the key thing is when you go into production, try and monitor that kind of the performance and try to make sure it's not declined too much, I would say. And hopefully if you've done your homework properly, you get similar performance to your back test. But that's the key point. When you go from a purely theoretical, like a back test, to a live environment, you've got to be aware of overfitting and that type of thing. So there's so many like products that are being made, like trading products and indices, where the back test is like this, it goes up and up and up, and as soon as it goes live, it starts to decline essentially. And often I would say that's probably because of overfitting on the history.
Okay, Anna, and moving back a bit to alternative data again, you've mentioned backtesting a bit, and I was curious what your approach is when it comes to kind of validating a model that is more kind of structured for alternative data, because I can imagine that either the data might be a bit limited or it might be a bit more complicated to kind of structure it in a way where you can validate it properly, or how do you approach that?
Yeah, that's a very good question. So in the context of forecasting, whether it's inflation or FX or anything like that, when you're doing a regression model, ultimately you need a time series to input into your regression. So if you have alternative data, typically the process from going your unstructured alternative data to a time series will be more involved. And that's even before you've done kind of additional feature engineering on top of that to combine maybe with other indicators and so on. So typically you have more steps. So if we think of text, one example is text. If you have a series of text, you need to be able to classify what the texts are about, add additional metadata associated with them, like the timestamps when they were created, what topics they're about, potentially what sentiment. Then you filter it appropriately. and then potentially create a time series of sentiment or novelty or some sort of metric. And that can be used as an input into your trading strategy. Obviously, that process of going from the raw text to the time series can be quite involved. And you've got to make decisions along the way as well in terms of how you do that. If we think of sentiment, there's many sentiment models out there. You could use an LLM for that and so on. So there's lots of different decisions you need to make before you construct the time series there. And you're right about the history of alternative data. It tends to be shorter. So we can't, for example, for our inflation forecasts, it doesn't really make sense for us to do a 20-year back test essentially and try and use that to understand how effective the model is. If, for example, we have, and typically I'd say most of the alternative data we have is, I don't know, 5, 6, 7 years, something like that. If we go back 20 years, there's very little alternative data in the model. So the performance of our back test going back 20 years would be very different to the performance over the past 5, 6 years when you have a very rich alternative data set. There are things that you can do. You can use imputation techniques as well, potentially to help, at least when you're forecasting more recently, to backfill the history. But that's not necessarily going to help again going back 20 years, because if you use imputation techniques to, say, generate the past 15 years of data when you have 5 at the end, and you're doing a back test, I don't know, 10 years ago, you have a lot of look-ahead bias. You can't really use it in that context. But you can use imputation techniques to do a backfill where you have before you actually reporting the forecast. That's not an issue about look-ahead bias and things like that. But imputation it's not magic, but it does help at least make sure that there's some sort of time series that you need to fit against, as opposed to the opposite point where you just have a flat line like a constant.
Okay, yeah, no, and on another note, I saw you also have a few open source libraries, like a few open source Python libraries, and I'm eager to hear a bit more about that and kind of the use cases of it.
Yes, I've got quite a few open source libraries, and most of them I think are open source maybe about 10 years ago. But throughout that time, I've basically maintained them because, for example, at the moment in Turnleaf Analytics, we actually use FinDataPy internally, which helps you basically download data from many different sources. We've adapted it for some internal sources we have. Also, we use FinMarketPy, another open source library that I developed for backtesting trading strategies. So whenever we come up with use cases for our trading strategies, we basically use FinMarketPy to do that. And I've just really enjoyed basically putting stuff into an open source environment for people to look at and so on. It would be great to have more contributors, I've got to admit, because I'm basically the main contributor for all these libraries. But I understand people are busy and so on and so forth. But if there are people that want to contribute to FinDataPy, to FinMarketPy, also my visualization library ChartPy, then please do let me know. Because I'd say contributing to an open source library is a great way to improve your coding, also to show people essentially what you're capable of doing in terms of coding, because it's all online and people can see it. So there are benefits from that perspective, and at least for me, I found it super useful to open source these libraries. And also I do a lot of teaching as well. So I teach, for example, I've taught at universities. I also teach on the QDC, the Quantitative Developer Certificate as well. So I use my open source libraries for teaching. I've taught at the hedge funds as well. So I found it useful for my coding teaching as well, my lecturing. So it's been nice for that. Also, I've been to a few hackathons where people have contributed to my open source libraries. But yeah, I've really enjoyed doing something open source, and it's kind of cool to see that. Look, there's, I don't know, 50,000, 100,000 downloads. I think probably it's even more than that of all my open source libraries. So a lot of people have used it, and that makes me feel happy that a lot of people are using my code and so on. But the nature of open source is often you don't know who's using it because it's kind of obviously anonymized and that type of thing because it's not commercial. But by the end of the day, if I've helped people learn about quant and stuff, then why not? And it's also helped to put my name out there as well. That's really important, I would say. So people know about your libraries and stuff. They know how you code and stuff. So that's obviously beneficial for me. But I would recommend for folks to open source stuff. Obviously, there's some things you can't really open source because they might be proprietary and so on, and I can understand that. But there's equally a lot of stuff that people reticent to open source, even though it's kind of commoditized. So I would say that a lot of stuff that people work on, you could potentially open source. Obviously, you've got to check with your company and so on. That's a different case. But even commercial organizations often open source libraries these days.
Yeah, no, but it's quite tricky to find good high quality open source libraries in the quant space. So I was curious if there's any like libraries that you are excited about that you've kind of seen that you believe there's potential to be found in it, or just any like larger open source quantitative libraries in general that you might use at your firms.
So I've used quite a few. Obviously, I use a lot of open source libraries. So one obvious one is Pandas for time series. I'm sure lots of other people use that. Also, Polars for kind of similar type of like tabular data as well. So I'm sure most of people listening to this have heard of those. But like specifically finance-based libraries, I know that Paul Billikon of like Telesians, he's got a few open source libraries that he's developed, and they're very nicely coded for finance. Kind of more on the pricing side, there's QuantLib, which is very well known for doing option pricing. I've used a library on option pricing by Dominic O'Kane, who is a quant in the city. He's now an academic. And FinancePy is really, it's quite nice to use. It doesn't have as many. It's not as kind of mature, I would say, as QuantLib because it started a lot later. But I found it quite easy to use and it's quite nice. And yeah, there's lots of different libraries that you can use. Obviously, we use a lot of machine learning libraries, not specifically finance based, stuff like scikit-learn and things like that. And we kind of use them as a base for a lot of the work that we've done on top. But yeah, I know what you mean. There's probably not as many finance libraries as you'd expect. I think one is because potentially a lot of people they can't contribute because they might be working in hedge funds and banks, and for obvious reasons they can't contribute that code. So that could be one reason. So I guess a lot of the libraries that you do see contributed are people kind of working independently, like in startups like myself and so on. There's also a library, I can't remember the name of it, but it's by Rob Carver. So he's written loads of cool books on trading, in particular trend following as well. So he's got a library basically for doing trading on interactive brokers and stuff. And I had a look and it did look quite cool, but I've not tried to kind of do my own trading through it.
Okay, Anna, and then you've mentioned that you've lectured a bit, and I was curious because a lot of the viewers are gonna be younger, aspiring quants. What some kind of skills are that you would suggest that they learn early on that maybe you didn't look at as early as you should have?
So I would say that like if you want to do quant and data science, I'd say like trying to understand statistics is important. And that doesn't mean just open scikit-learn and so import scikit-learn and so on and use it. It's more about understanding how like a regression works and this type of thing, what stationarity is, understanding things like seasonality, and like basically just generally understanding statistics, and also try to fuse that with understanding coding as well. How you develop a library and understand like software engineering and this type of thing. So it's one thing to be able to code, but it's another thing to actually code a nice framework and like a bit of thought behind the design. So these are the two things which I would say are important. And obviously, once you start working to fuse that with market knowledge, because like having domain specific knowledge is like I'd say like a massive shortcut whenever you're doing a model. Particularly say for example inflation. If you understand what drives inflation, then you can understand what that type of best approach to finding data is for it and so on. That's the same if you're modeling FX, fixed income, or anything like that. Having the specific domain knowledge is really what will be your added value, and combining that with kind of analytical and coding skills. But I'd say the main thing is just do something you enjoy. Like if you enjoy maths, you enjoy coding. That's the main thing. So that's the way that I
Okay.
approached it when I was younger.
Yeah, yeah. And then kind of looking forward into the landscape, especially out of the ML side, how do you see the quantitative landscape evolving over the next couple of years?
So I think definitely machine learning is a big thing. I just went to this WBS Quant conference last week, and like 5, 10 years ago, there was no talk of machine learning at all. Now, most of the conference is machine learning, obviously stuff on option pricing and so on. So I think machine learning will become more embedded in quant space. And these days also, there's a lot of talk about using agents as well. So how do you get AI agents into production? Do you want the AI agent to do something meaningfully for you, or do you want the AI agent to generate code for you that you inspect? So this, I think, is the way that quantitative finance is going, definitely embracing machine learning and AI agents. And indeed, like what we're doing in terms of forecasting inflation with machine learning and alternative data is kind of one of those aspects in terms of trying to push time series forecasting to kind of a new approach essentially from a finance perspective.
And then you also mentioned large language models. I mean, it's the talk of the time really. Large language models and agents. And do you think that that will have like a tangible effect on quantitative finance moving forward? Because I know there's talks about it struggling with mathematics and so on. So what's kind of your take on using it and implementing it in maybe your own firm, or just like how the larger firms are doing it in general?
Yeah, so I would say that LLMs are very suitable for many tasks, particularly tasks which a human can do, basically, those types of tasks. But I would say, for example, specifically about time series forecasting, models which are basically similar to LLMs, but using like sequences of data, basically, they don't seem to have shown as much in the way of efficacy in terms of like result accuracy. So trying to use these types of tools for doing time series forecasting, I'd say, is not really the right approach. Maybe this will change in the future, but at this stage, I'd say that kind of the more traditional approach is even in OLS or something like that, although potentially that's not suitable for large data, so we don't really use them in our case because of that. I would say that LLMs kind of struggle with time series forecasting. So whilst they are the talk of the town, like you say, and they're very good at many tasks, I think time series forecasting needs a slightly different approach, and that's what we have found. That being said, we do use LLMs, for example, to help us search through news data, to help us improve our models, to help us code, and so on. So it's all about finding the right tasks for an LLM to do, as opposed to trying to force it into every single sphere. It's like using an LLM to multiply together two numbers, and it has problems doing that. Like, okay, just don't make it do that. Like, we know it's not really good for those types of tasks. So instead, use other types of tools for that. So that's what I would say. Understand where LLMs have a strength, but equally understand where LLMs have a weakness, and kind of use them accordingly. And I still think we probably don't really understand that question fully. It's going to take a lot more time and experimentation with LLMs to kind of get there, to understand what their features are.
Okay, I know. I think that's all for today. I think we touched upon a few very crucial topics, and I found it extremely insightful. And I want to thank you for giving your time to answer a couple of interesting questions around what you do.
No, thanks very much for the invitation, Johannes. And yeah, I think it's cool what you're doing and trying to get kind of more young people interested in quant and data science. It's especially data science. It is the future, so it's important to kind of embrace and understand what's going on in this space. So thanks for the invite, and see you soon.